And what I am going to talk about today in this video is comparison operators, where we actually go and carry out comparison on different variables to see whether they are true or false. So we will be using returning the Boolean operation, so we can results which can be by saying is something equal to something. I need the Boolean to return some Boolean operator to say yes, it's true or false. So this is the first thing. Then I will look at the use of if else statement and how we can actually use them before we enter into the loops, because in the next Jupyter Notebook I will also be going into talking about loops. Therefore, let's start and not waste any more time here. Now, in the first cell, what I am trying to do, I want to check if something is equal to something or if it's not equal to something. So what do I have? I have a variable called result equal, and I'm saying is 5 equal to 5, and it's true, so therefore it should return true when I execute this. And the second one, result not equal to, is a variable, and I'm saying is 5 not equal to 7, and again it should return true for me. So if I run this cell, it should give me true. Now if I change this variable to 7 and this variable to 7, and if I run this cell again, it should actually give me false and false, because 5 does not equal 7, and 7 actually equals 7. Therefore, this not equal does not give me the true. It actually will give me false, because 7 is equal to 7, which is opposite to what this statement is trying to show. So if I bring this back to 5 and 5, and if I run it again for the sake of this Jupyter Notebook, it should actually give me true and true. Now for not equal, I said 7 is not equal to 7, which what I did there to try, and it goes and give me false. So I will keep that there for you, so you know the difference. Now if I want to check if something greater than something else, I will use the operator greater, and this should return for me true or false. So if this was 7 greater than 5, it should give me true. But because I'm trying to check if 2 is greater than 5, then it's false. And when I use this in a condition, as a condition in some case, then it should actually either say true or false. And if I use it as a stopping condition, then it will be very successful, because it will return false and I can exit from that condition. Okay, so if I run this, and it should give me false. But if I say is 7 greater than 5 and I try to run this, it will change to true. So I bring it to here to actually match with the print statement. But please play with these values so you can actually do it. Another operator is less than, and I'm saying is 3 less than 8? Yes, it's less than 8, therefore it will return true for me. So this is how it's done. And then is 10 greater or equal, and in here I'm saying is it greater or equal. If it's greater, is true. If it's equal, is true also. Therefore, if I run this, it should give me true. If I make this equal also, it should be true. So, and if I change this to greater, I want it to less or equal, it should be true. And if I change this just to less, then it should be false. Okay, so you need to understand the difference between all these operators which we are trying to check. Okay, the next one is chaining comparison, where I have a value x and I want to say this value is greater than something, but it's actually less than something. And if I run this, is x greater than 1? Yes. Is x less than 10? Yes. So if I run this, it should actually give me true. Now, if I change this to actually 11, sorry, x, not here. If I change this to 11 and I try to run this, it gives me false. Because yes, x is greater than 1, but it's not less than 10. It's greater than 10. Therefore, this condition, if one of them is violated, the whole condition is violated. Okay? So if I bring this back to any value within 10, then it should actually be true. Okay? Now, how do the if statement work? They are very simple. A condition need to be satisfied, either true or false, for this condition to actually execute. Then it has to be uh, true. So if I say that x is equal 10, if x is greater than 10, it's not greater than 10, then it's actually x is greater than 10, but it's not. So if I run this, it should say, sorry, but x is not greater than 10. And what happens? It didn't run, it didn't execute. Okay, so for this condition has to be satisfied for this to actually, for this statement followed the if should be executed. Okay, so if I change this into 11, then in this case it should execute, because yes, x is greater than 10, therefore it's within the condition, is satisfied, is true, then this statement will run. Let's try and see. Yes, x is greater than 5, but I am not actually saying 5, I'm saying 10 here, because I changed the values in the previous. So if I run this, yes, it's greater. Now, if I bring this to 10, and if I run this, it shouldn't run, because 10 is not greater than 10. 10 is equal to 10. Okay, so it will bring false, and because it's false, then the if statement will not execute. Okay, it will check, but it will not execute. Okay, I have if else statement, because if one statement doesn't run, then we have a default statement that actually going to run. So I have a variable y, and I'm saying is y greater than 5, and it's true, therefore this statement should run. Okay, so if I run this, yes, y is greater than 5. But if I change that and make it 3, and I try to run this, statement will not run, but I have a default statement which is else, then it says y is not greater than 5, and let's see if it's actually true. Yes, is not greater than 5. So it actually, these conditions will, based on true or false, will allow this if statement to execute. We have to check the condition, and then based on the return from that condition, whether it's true or false. If it's true, it will execute the statement following the if. If it's false, it will not execute anything. And in this case, because we have a default statement, if this doesn't execute, then this one will execute. Now let's have the else if statement there. I have a variable z, and I assigned 5 to it, and then I said is z greater than 10? It's not, therefore this will not execute. Then I said is else is z greater than 5? It's not, then this one will not execute. The default is z is 5 or less, okay, and it should execute. So let's try executing this, and it says yes. Now let's change 5 to 15, and if I try to run this, the true one is this, okay, and it should run. So let's see. yes is greater than 10. Even though z is 15, which is greater than 5, we only execute this statement because it actually was the first one. It doesn't go to the next one because in this if else statement, it will only execute one. The first true one will be executed. Now, if I made this into 7 or 10, let's say, and then if I run this, the first one is not true, therefore it will not execute. The second one is true, it will execute. And the third one, the default one, will not, because since this one ran, it will stop. That's it. We only need to run one of these at any one time. So if I run this now, you can see z is greater than 5, but not greater than 10, because it's actually equivalent to 10. So this is how it works. Now we can also use nested if statement, if else statement, which means to actually go into the nested, then I need to have the condition, the original condition, true for us to go and execute these statements. But the statements is a set of statements that contain an if statement. That means if this is true, then I need to go and check if this is true. If it's true, it will be executed. If it's not true, then it will actually go and execute this one. And if this is not true from the beginning, then the default for that if statement will be executed. So let's try and play with this. We assign 10 to A, and then I'm saying, is A greater than 10? It's not, therefore it will not execute any of these because we didn't go into that if statement. We didn't execute that if statement, and it will execute the else statement. So if I run this, it will give me A is not greater than 10. But if I change this and make this into 10 or 11, doesn't matter, and if I run this, and let's see what happened. A is greater than 10, A is 10 or greater but not greater than 15. Okay, what happened? We actually went in here, it's greater than 10, but it's not greater than 15. So we printed this statement here, which is this first statement here, to say that we entered into that if statement, the first if statement. Then we have a condition. Is A greater than 15? No. Then it will go and execute else. And else says A is greater than 10 or greater but not greater than 15, which is this statement here. Now, if I make this into 16, which I want to make sure that I execute this if statement, then if I run this, I say that A is greater than 10 and A is greater than 15. Therefore, I executed this because I entered into the if statement, and then I check this condition and it's true. Therefore, I execute this statement. This is how we can actually do nested if statements. So it's very simple, very effective, understanding the actual condition and the result that comes out of that condition. So it's good to actually use these things, and it will be very, very useful for us as we go and progress and start building something more complicated using the Python code to build our machine learning models. Now we can also have a combination, combining conditions. Okay, I'm saying that temperature is 15. So I'm checking to say if temperature greater than 30, we actually go and print. If it's else 20 is less than or equal to temperature, and this is less than 30, if that's satisfied, then I have two conditions here. I have it sitting between 20 and 30. If it's sitting between 20 and 30, then it's fine. If it's greater than 20 and less than 30, then this else if will execute. Else the default, it's cold. And I want to say it's the outside temperature is hot, or it's pleasant, or it's cold, and I put the condition. So the temperature is 15. Is temperature greater than 30? No. Therefore, this one will not be executed. Is 15 greater than 20 or equal to 20? No. Even though it's less than 30, violated one of them, therefore this condition is violated. It will not execute the else statement. Else if, sorry. Then the default one, it's a cold day, because we have defined that 15 is cold day. So if I run this, it should actually tell me it's cold day. Now if I change this to make it 25, then it should satisfy this condition here. It's less than 30 and it's greater than 20. So if I run this, the else if statement should execute. Okay, and it says it's a pleasant day, because this one is not greater than 30, but this condition is satisfied. It's less than 30 and it's greater than 20, therefore it's satisfied. So you can see how we can actually apply these else if or if else statements. Now using if in list comprehension, which means I want to use the if statement within a loop, a for loop, and this will be very useful for us. And what I want to do, I want to select only odd values. So what I did, I created a list which contained 1, 2, 3, 4, 5, 6, and then I wanted to take the even numbers, and I said, is it equal to the number which is returned? The if condition will check if the number value, the return, the modulus of that is actually equal 0. If it's equal 0, then it will add it. If it's not equal 0, it will actually not add it. So if I say equal here, this will actually check for the even numbers, because it equals 0. We take this one and divide it by 2. Does it equal 0? No. Then we don't include it, because the if statement is not true. If 2 divided by 2 is 0, yes, we will add 2. 3 is not, 4 is, and 6 is, and so this will actually give me the even numbers. Now what I had it originally as, I had it as not equal. And if I change that to not equal and change this to odd here, then it should actually show me the odd numbers. Now I'm not going to change the print statement. I'm just going to change this to not equal. Okay, and if I run this, now it actually selected the odd numbers for me. So this number is actually written, but how I check all these numbers in the actual set, which is numbers, and then I pass the condition if the individual value, the modulus of that individual value equal to or not equal to 0, then I select the number. If it's not, we will skip it. Okay, so originally I had it as equal, and that will give me the actual even numbers, which will match the print statement here. So this actually takes us to the end of this Jupyter Notebook. I will jump straight away to the third Jupyter Notebook, and in here I'm going to talk about loops. Now I have just showed you in the previous Jupyter Notebook, the last cell was actually a for loop, and how we used it to actually iterate and select even and odd numbers. I will start by creating a list of text, and then I am actually going to iterate and print the individual components within this list. So I created a simple for loop for fruits. So I am saying it's in that I called the list in fruits, which is the component, the individual components, and I wanted to print fruits. Now look at this for loop. It's for and it's terminated by colons. Now when you hit the return here, it brings you to this location. This is the indentation at which it starts. If I go and write it like this, it will actually print nothing, because it will not give me fruits here. So I have a mistake. Print statement, the indentation is actually wrong for it, okay, because this is supposed to be in the for loop and there is nothing in the for loop. So all I have to do is just to correct this, and if I run it, it should actually work for me. It iterated through the component and just printed the actual values that are stored at the different indexes within this list, because it goes to the first index, which is 0, and then prints whatever at that index, okay, and then it increment the index and go to the next index. It started at 0 by default, then it's gone to 1, and it will print that. Then it will increase by 1 to 2, and it will go and print what's actually stored, and there is no more to actually go and check. When you go to find the next index, there is no next index, so you know that you reach the end of that list, so you exit, and that's your results. Now if we have another component there, then it should keep moving. Now this is a string, and we want to loop through this string, and the string is also made out of these characters, and each character set at an index value within the string. So this will be index 0, and this will be index 5. Okay, so if I want to iterate through these, then I will say for character in word. Okay, so I'm looking for individual characters in word, print character. So it starts with index 0, and it will print what's sitting at index 0. It will increment the index. It will go to index 1, which is this one here, y, and then it will print the y. Then it will increment the index to 2, and it will go to the third index, which is number 2, and it will print what's there, and it will continue until it reaches the end of that text or that string value, and then it will actually exit the for loop. So if I run this, it should actually give me these individual characters which make this word Python. Now also I can use this function range to generate numbers up to 5. Okay, so it will go to index 0, 2, 3, 4, and 5, and it will actually go and print them for me, and it will imprint the index value itself, which is I. For I in range 5, and you can see it actually counts to 5. 1, 2, 3, 4, 5. At 5, it's actually index 4, and at 1, it's index 0, and that's what it returns, because the first index is 0. It will go to 5, and then it will actually stop at 5, and at 5 it's index 4, and that's why it actually give me that value. So if I run, it should actually, so this range function actually generates these numerical values which incrementing. So it creates 0, and then it increments to the next one, which is 1, 2, and so on, and this print statement keep printing the value of I. So I starts at 0 and it stops at 5. Okay, using enumerate function, which means that it actually will iterate over the fruit function, the fruit list. I have a list which is called fruit, and I have a function which is called enumerate, which means it will actually iterate over the content of this list. So for index fruits in enumerate, and I pass to it the individual components of this. So if I pass to it this fruits, it means it will actually look at the first value, the index, which is which we are going to enumerate over, which is 0, 1, and 2, and then it will go and print for us the index, and it will print for us what's actually stored at that index. Okay, so the first index, and I use this if format statement where it's simple. I use if, then I say it's a formatted list, and in there I say I want index, and then I want the index value printed, and then I want a colon, and then I want the actual keyword, which is fruit, inserted in here. Therefore, it will go for the first index is apple, second, zero index is apple, first index is banana, and second index is fruit. And then it actually stops because there is no more there to increment. So if I run this, now it actually gave me these values, which are index 0 contain apple, index 1 contain banana, and on the index 2 contain orange. So I can use this to do too many things, depending on what logic I am trying to execute and what am I trying to read and from which location, and if I want to change these values, assign them, or if I want to select certain values and use them in another function to execute some logic that I try to achieve. Now we can also look at nested loops. So we have a loop, for loop here. This is the original for loop, and I have some value I, and it's going to be in the range of 2. And within that I0, I have to go into another loop where I have a j, and this j also have a range of 2. And we know that the function range just create these values. So it starts at 0, 1, and 2, 1, and 2. So it's actually trying to generate these values twice. And in here it will generate 2 values, and in here it will generate 2 values. So for I in range, it will actually say I have maximum of 2. So we look at the first value, which is 0, that this range initialize with, or give me the first value as 0. Then I have for j in range again, and it's 0. It starts at 0. So I have I0 and J0, and that's what I have because I've used this formatted if statement to print I and J, and I know that in the first round I have I0 and J0. We are still in this I because in here J is actually going to iterate for the second value, and it will go to 1. And it will print I still 0 because we're still in that for loop, and J now is 2, and range is finished. Therefore, now we can increment I and come back to the first loop, and now I is 2, and we can go into that second for loop, and J now is 0 for the first one. It will increment to 2, so I have I is 1, and I have J is 0, and then I have I is 1 and J is 1, and we see that we come out of this, and when we come back here, we come out of this because we have already reached 2. So this is how we can create nested loops also, and it's a very nice way of using this range, and we will be using len, range, and enumerate quite a lot in our loops as we can go forward. Now we have this dictionary, and we've seen how to create a dictionary, and what we are trying to do in this dictionary, we have actually assigned first key and John, second key 30, and third key city, which is New York. And then I want to iterate in this and select values. Okay, so I said for key, which are these are the three keys we have to iterate over. Value in person, which is this dictionary here. Items, I want to iterate on the items itself. So I will look at item 0, item 1, item 2, item 3, 4, 5, whatever the number of items we have in this dictionary. And I use this formatted if statement where I will print the key and followed by this colon, and then I will print the value at that key. So if I run this for loop, then it will actually go to the first key. It prints the key for me because this will actually print the key and this prints the colon for me, and then it goes and print the value assigned to this key, and the first value is John, then the key is name, then the second key is age, and the value assigned to it is 30, and then it goes to the third key, which is city, and the value assigned to it is New York. So we can also iterate over items within either a list or a dictionary or an array, whatever we already have. We can also iterate by using this item function, which actually starts by generating the values starting from 0, and it keeps going, or it looks at the key value, first key value, second key value, third key value in a dictionary, and so on. Let's see how we can actually break this state. We can break out of a statement, or we can continue. So let's see. I have this list which contain 9 numbers from 1 to 9, and I use a for loop which actually iterates these numbers within this list. And I put an if statement. I said if num is equal to 7, break, i.e. we do not execute anything here. And then we go to the next statement, which says if num and divided, and we're looking for the modulus, the return of the division by 2 does not equal 0, then we continue. If it equals 0, we actually print the number. Let's see. If I run this, it actually gives me 2, 4, and 7. And let's look at the logic of this. We look at the number 1. Is it equal to 7? No. Therefore, we do not execute this. We do not break. Okay? Therefore, we need to go to this second if statement. This one, if divided by 2, is the modulus not equal 0? It does not equal 0 because it actually equals half. Therefore, we continue. And that's what happens. And we print the num. So it does not. If it does not, if it equals, then we continue. If it does not, then we don't. So if I change this to equal, let's see what happens. If I run it, I actually selected the odd numbers. Why? Because continue means bypass. Okay? So if it doesn't equal, then we are printing the odd ones. So if it actually does not equal 0, we ignore that and we go to the next one. Okay, so this is how it actually runs. Let's look at looping through a list in reverse. I want to go from reverse, and in this case Python provides me with a function called reversed, i.e. it goes to the last index and it will decrement the index until it reach 0. Okay, so in this case I said for fruits, which is this here, sorry, these components in reverse, and I pass to this reverse the actual list which I have, and it will go to the last component in the list and it will print for me, and then it decrement the value. It goes to index before last, and it also print, and it goes to the index after that, and it will actually print, and then it tries to go and there isn't, so it knows that it actually reached the end of this list, so it will actually exit. So when I run this, it actually works nicely. While loops, even though if you are using for, most of the time you try not to use the while loops, because it's much easier to use for loops than it is while loops. But we need to actually go through and see how the while loops work also. The while loop is actually repeatedly execute a block of code as long as the condition is true. So the difference here, we actually initiate the variable we are actually going to iterate over before the loop. And then when we go to the loop, we just check the condition, and then we increment the value within the loop until we reach the end of that condition. So I have count in this basic loop equivalent to 0, assigned 0 to it. Then I said while count is less than 5, we execute these. So print count and then increment count again. And now count is incremented by 1, still less than 5. So you go and execute these statements. So if we run this, it actually works. The first one is 0, it's less than 5. So it prints 0. Then it incremented, it's 1. 1 is less than 5, so it prints 1. Then it actually incremented, so it's 2 less than 5, and it continued to 4. And then is 4 less than 5? Yes, it's actually less than 5, and it will print 3. And then at 5, we come back here. Is 5 less than 5? No, it's not less than 5. So what do? We stop. So when it's violated, it's not true, then this is not executed. The last one would have been is 5 less than 5, which means it will have to give me the content of index 5, which will be 6, because we start from index 0. This is 1, 2, 3, 4, 5. So this is executed 5 times. 0, 1, 2, 3, 4. Okay, and every time, once the last one we go, we actually increment and test. So in this case, we have to go and test for the last condition, but we do not execute. So in terms of complexity of code, we actually do more calculation here than we do with the for loops. Okay, so let's look at breaking in a for loop. Break, and what does that break means? It means exit, and continue it means is you actually continue. So I have a number assigned to it 1, and then I said while true, print number, and I put the condition inside the loop there. If number equals to 5, break. Okay, which means I do not go and increment the value again. So let's see. Run this, and it gives me 1, 2, 3, 4, 5, and that means if it reached 5 and I have number equal 5, at that point we break, we come out of the loop. Okay, so if I change this to 6 and I run it, you can see it actually reached 6. If I change this to 3, it actually should if num equal 3, and if I run this, it actually goes up to 3 and stops. So this is how it works.